Greetings to everyone. Welcome to this other tutorial. Here we are going to see how you can read analog signals using analog to digital conversion. So this case study, we are going to look the temperature sensor device, how you can interface it to it, your microcontroller. So here, the temperature sensor that we are going to use here is the LM35. The LM35, you can go to the component mode and the library to pick your device. If you type LM35, you're going to see the temperature sensor. Then we have the Arduino Uno microcontroller, which we are utilizing, and the 16 by 2 LCD. I've already showed you how to interface an LCD, so you do the connection appropriately. So here I'm going to guide you on how to code this in the Arduino IDE. So here we have our 5-volt DC supply. I'm going to teach you how you can build a 5-volt DC supply. So here is just a block showing you the 5-volt output. If you want to utilize a 5-volt output, you can come to terminal mode, then the power, you click on power in the workspace, then you double click on it and then you select VCC. So that will give you 5-volt. You can connect this your 5-volt to any pin or any point where you want to supply with 5-volt. But I will teach you in a different tutorial how to build a 5-volt DC supply from your 220-volt AC supply. Okay, let's proceed to the code. But before that, note the pins. Here are the analog pins of the microcontroller. So these analog pins here, written from A0 to A5, permit us to connect analog devices to this pin. So for example, here I've decided to use the pin 5, A5. That's the analog pin number 5. You can decide to use A0. It depends on you. Then for the LM35, here pin 1 you supply with 5-volt, then pin 3 to the ground, connected to the ground, and pin 2 is the output pin. So V out, it gives out a voltage signal at pin 2. You know that temperature is analog signal, meaning that the signal is continuous with time. So you need a microcontroller to interpret this continuous signal. Okay, then the pins to which the LCD are connected as well. Here we have RS connected to pin 13, EN connected to 12, D4 to D5 connected to pin 11, 10, 9, 8 respectively. Then you have the potentiometer here in order to vary the intensity of the LCD, intensity of light on the LCD. Okay, then this here supplies the LCD. We proceed now to the coding. So here is our code. First, we begin by including the LCD library using the command LiquidCrystal. But here I've showed you how to include this. You come to Sketch, then Sketch, include library, and then you select the LCD, LiquidCrystal. Here's it. So once you select this library will be included as such. Then we configure the pins of the LCD. So by using this command LiquidCrystal LCD, the pin to which RS is connected, the pin to which EN is connected, the pin to which D4, D5, D6, and D7 are connected. Then we note that we have to read the analog signal. And in order to read this analog signal, we are going to use the command analog read, in bracket the pin which we are reading that signal from. Remember, we are using the analog pin 5. So we'll be using this signal, this command or the syntax analog read in bracket A5. So this will permit you to read the value given at the output of the analog of the temperature sensor. Okay, but note that this value is still a raw data in voltage voltage. So you need to convert that value to the actual value of the temperature. And to do that, to uh, 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 you have to use a certain coefficient which is given in the data sheet of that analog temperature sensor device. So in this case, that coefficient is 0.488 or approximately 0.5. So the value which you read from the analog pin here, you are going to multiply that value by 0.488 to give you the actual temperature value. And note that these values are the temperature, you can have a value in decimal point. So you need to declare the variable there as a floating point number, because a floating point number is a number with decimals. So that's why I'm going to attribute, for example, I'll declare this variable temp as a float number. So this temp here, I want to write temperature. Sorry, you can write temperature in full. I choose to write temp. So I defined or declared temp as a floating number. So I want to attribute the signal that I will read from that analog pin to this temp. That's why here I say this analog read at pin A5. I attribute it to temp. That's why I say temp is equal to analog read. I'm sure you understand this. Okay. But now I told you this is raw data. So any value you'll be reading, you attribute it to temp. So make sure you always declare what is that temp. That is my temperature. But now the actual temperature value is what we have to process. Now, the actual temperature value will be this temp times that 0.488, that coefficient. So I also declare that actual temp here is a floating number. So I attribute the temp times that coefficient 0.488 to actual temp. So this is my actual temperature value that the microprocessor has interpreted, which I would like to display on the LCD. So in order to interface the LCD, you already know the commands. In the voice setup function, I'm going to begin by initializing the LCD using the command lcd.begin. Since it's a 16 by 2, I put in brackets 16 by 2. Then I clear the LCD using the command lcd.clear. Then I set the cursor to the first row, first column, here, which is given by 1, 0, lcd.set cursor. Then, since it is on the first cursor, I can print temperature. I say lcd.print. Now, here I am printing I am printing here temperature value. So it is temperature, sorry. This is a character. So it is in quotes. It is in quotes. So on the LCD, you're going to see this temp is equal to. You can decide to write it in full. Temperature is equal to, right? I can say temperature. Let me just use temp. Note that this temp here is different from this one. They are not the same thing, because here I am putting it in quotes. So here is a character to display. Then what I do now, I've configured the LCD. I come to the void loop function. Since you need to continually or continuously read the temperature value from the temperature sensor. So you need to put it in a loop because the temperature might change at any given time. So your microcontroller should be able to detect it at any given point in time if the temperature is changing and update it on the LCD. So here I've already explained. Here is reading the temperature and calculating to have the actual temperature. Then I set the LCD. I know that here on the LCD I've displayed 1, 2, 3, 4, 5 characters, right? So to start displaying it where this one ends, that is on the seat column of the first row, I'll write here 7, then row 1, which is 0 here. So LCD does set cursor. I set my cursor where this one ends because here I've displayed 5 characters, which is 5, 0, then 6, 0. To continue from there, it is on the seat column, which is 7 here, then first row 0. So LCD does set cursor. Then I use now the command lcd.print to print that actual temperature. I put in bracket actual temperature. But note here that this actual temperature is not in quotes because here it is a string. That means this value here, actual temp, note that we calculated temp times 0.488, it will give us a value. That value is stored in actual temp. So if we want to display that value in actual temp, we simply put that actual temp here without a quote. Please note this, without a quote. Like here, you see here has a quote, unlike here, you see it has a quote. When it has a quote, it's going to display here, but temp is equal to. But when there is no quotes, that means that you are not displaying actual temp. You are displaying the value stored in actual temp. So that's the difference, right? String and a character. You have the difference between a string and a character. So where that cursor has been set, you start displaying now this value in actual temp. Then I display something again. If I want to continue displaying, I can use the command lcd.print line. Line simply means where the LCD cursor stop, continue from there, right? So rather than using lcd.set cursor to put the column number and the row number, you can still use the command lcd.print line. So it will continue from where the LCD stop. Then I just want to display degrees Celsius. So I'm putting in quote the star Celsius. But note that degrees, you can actually print degrees using what? The character number on the ASCII table. We are going to look that one after because you need to consult the ASCII table character because every special character has its value. So we can use that special character value on the ASCII table code to display the value, the special character, for example, degrees. So I'm just giving this so that uh, you can just utilize this for the moment. I'll show you how to print degrees. Then I give a delay of 2 seconds. I can give a delay here of 1 second. Yeah, depending on how frequent you want to update the reading. 1 second can be good. Yeah. Okay. So simulate, compile, done compiling. I'll show you how to include the hex file. You copy from C here to .hex. Okay, from C here to .hex. When you've copied that, you go and paste it in the Arduino. I use Control C to copy. I double click and I paste it here. Okay. Then we are good to simulate. So I simulate, you see temperature is equals to 30.26 degrees. Note here that here is a temperature sensor. So the temperature sensor is sensing 30 degrees, right? So you can increase the temperature here, probably, or reduce the temperature to 29. See, it has dropped to 29 degrees. I can keep reducing. You see on the LCD it updates to 28. I reduce to 19. You see it updates on the LCD. You can choose to increase the temperature sensor. So you see that we have interfaced this temperature sensor accurately, right? 52 degrees Celsius, the temperature sensor is displaying the temperature. Okay, so this is how you can interface a temperature sensor. One thing I want to add again here is how you can use the serial communication in order to send, for example, this temperature value or any other information through serial communication. You know, through serial communication, you can use different devices like, for example, the GSM. You want to send this data to someone in his phone SIM card. You can use a GSM, or you want to send it through Wi-Fi. You can use Wi-Fi module. You want to send it through Bluetooth. You can use a Bluetooth module. So in order to do that, you need to utilize these two pins. Let me stop the simulation. These two pins here, we have TX, which is transmission or to transmit. Then RX is receive data. RXD, receive data. TXD, transmit data. So these two pins, pins 0 and pin 1, are used for serial communication. So in order to do this, I would just come uh, to see the data which you are transmitting. If you are transmitting accurately, we can come here to terminal mode. Sorry, not terminal mode. We have a graph. Okay, this instrument. Then you take a virtual terminal. Okay, so with virtual terminal, you put the virtual terminal here. Since we are transmitting, you connect. Since the microcontroller is transmitting this to the module, you connect this TX to the receiving pin of the module, which is RXD, right? Okay. So with this, you can actually test if your transmission is actually perfect or actually working appropriately, if you're transmitting the data appropriately. Okay. So we'll go to the code to modify. We need to initialize this serial communication device by using the command serial.begin in bracket 9600. Here is the baud rate, the baud rate. So using this command, we have initialized the serial communication. Then now we want, as we have displayed this temperature on the LCD, we want to, for example, send this temperature through serial communication to the serial communication the serial communication device, might be your Wi-Fi modem, GSM, Bluetooth. Yeah. So we are going to use the command serial.write. And if you're writing, we want to write, for example, temperature is, that one is a character which you would display. Then we write the actual temperature value. So cr.print line. That means that where this temperature which you have displayed column ends, you should continue from there to display now the actual temperature value. So you see that this actual temperature value is not in quotes. So rather than displaying actual temp, it will display the value stored in actual temp, right? And then you can give a delay of 2 seconds. So this should be in a void loop. If you compile, done compiling, you come to the simulation, we stop, okay, then we run. You see here, the virtual terminal is actually displaying after 2 seconds. So if we increase the temperature, for example, to 32 degrees, you see it updates the data that is being transmitted through the serial communication, right? You can reduce it. The temperature is decreasing to 25 degrees Celsius. You see as it is transmitting that data accurately. So this is how you can interface the analog devices and also use serial communication. So thank you very much for following. Please like, subscribe, and share.